going to do today is get started with the policies for the class and how the class will run, and hopefully get to some lecture. So to start off with, we're going to use clickers in the class. At this point, there's only one student who has the clicker registered, and the registration is not something that you can do right now. Well, I mean, you could spend the next 5 or 10 minutes working on it, but I don't want to spend that time. So I'm not going to have people answer this with clickers. So I'm just going to have show of hands. How many people here because it's required for science majors? Okay, that's just a really large number in both classes. So I'm just going to put large. Not trying to count everyone. How many here because it's required for union scholars? One. Obviously, none of them. How many are here because it's required, and some of these you'll have multiple reasons. How many are here because it's required for a pre-professional program? Okay, that's, yeah, maybe a little less than half the class, maybe. Required for some other major I didn't list? Okay, that's more than I expected. For general education, physical science. Really? This isn't the best choice for general education, physical science. The reason is there are a lot easier classes. But if you're here because it's fun, then it's a great choice. How many people are here because physics is totally fun? Okay. There was a handful there. Let's say 5-ish, counting me. Okay, so I do this demographic breakdown. Of course, if we had clickers, it'd be better because you could actually see actual numbers instead of a lot. But so people understand there's different reasons for different students to be here, but we all have things that hopefully we'll get out of this. Now, one thing I want to bring out right away, we go to Loma Linda periodically for pre-professional advising workshops to work with us on how to advise students and whatnot. By the way, I'm the pre-dental advisor. I also do some advising in pre-med and a few other things. So if you're pre-dent, I should definitely be somebody to talk to periodically. And a question that's asked is, why is physics required for dentistry and medicine? If you're going into dentistry, going into medicine, you're not specifically using physics a lot. My students do say, yeah, we were totally using fluid dynamics, and we were talking about the blood, flowing through the blood vessels and whatnot. But for the most part, it's biology. And the answer that's given by people there at Loma Linda is that this class is required because the class requires you to do critical thinking in a different way than you get from your other science classes. And so one of the emphases of the class is how you think about problems. It's not about getting the right answer. Now, getting the right answers is important, but that's not the most important thing here. It's how you think about it. So in things like the test problems, you only get 1 point for getting the right answer. Your credit comes from the process and showing that you understand what was going on in the problem, that you're able to think your way through it. So let's look at the syllabus here. There are the two variations, but for the most part, they're the same. So we have the obvious things here like when is class? Class is from 11 to 11:50, Monday, Wednesday, Friday for this class. Now, people who are taking the calculus-based class will also be meeting in the same classroom at 11:30 on Tuesday. So I'll see you guys again tomorrow at 11:30. And then we have lab from 2 to 4:50 p.m. on Tuesdays, starting tomorrow. So tomorrow we need to be here at 2. The book you have to buy, this book I wrote, the lab guide. That's the only book you have to buy. It should be in the bookstore. So make sure you bring that with you to lab. Read through the lab guide before you come to lab. You have things like discussion of how to make your write-up and how the scientific method is going to be used in the lab. A lot of people get frustrated with the scientific method portion, but I think it's important because it's developing thinking like a scientist. So make sure you do look through it and know what we're going to do before you come to lab so that you're not out in left field. Okay, the objectives of this course, we want to understand the basic concepts behind physics and be able to solve problems. So understanding the concepts, that requires no math at all. Solving the problems requires a lot of math, right? You're going to have to do a lot of algebraic manipulations and things like that. So we want to be able to understand problems and solve problems and understand the scientific method because all of our understanding of science is basically developed by following a procedure of inquiry, the scientific method. So, we'll talk more about scientific method in lab, but that's a big goal here. I also want students to understand how physics really is important to your lives. A lot of us have things like our iPhones. Well, the iPhones are pretty much marvels of physics. You have all these physics topics that people have studied and learned about, and then engineers, I know I have a number of engineering students here, engineers take that information and they design really cool things from the information that the physicists get. Last two things, basically understand nature. The best thing that I can have for an outcome for my students is when they're driving down the street and they see a car off the side of the road on an icy day, instead of saying, poor sucker, they say, coefficient of friction was too low. And, think about the actual process of why that car went off the road into the ditch. Now, the classroom decorum, especially because we have the two classrooms, I know they can't tell when I'm looking at them. Especially because we have the two classrooms, it's important to try to keep things so we're not interrupting and causing problems. Now, something else that's not listed here, I should say, cell phones. I should take that out because with our new clickers, your cell phone is an option for the clicker. And so, people are using their cell phone as a clicker. Of course, you're going to have your cell phone out. But we don't want them ringing. I don't want you sitting there texting away. And so I'll get on more of that. There's another rule that is this building wide. If you're at a blacktop desk, you're not allowed to have any food or any beverage. Now, I see a lot of people in violation of that. A simple fact is, for this classroom, it's not really an important rule, right? It's a safety rule. We don't want people mixing their biological crud with things that they're eating. But because it's a building-wide policy, I hope that you will respect the policy. And, in the future, obviously, I know that you guys didn't know when you came in necessarily. Oh, there's a sign outside. Nobody reads the sign, right? It's only when it's pointed out, you're all, gee, yeah, there is a sign. Okay, so just try to refrain from that. If you have a learning difference, make sure you go to the TLC and work through their process, and they will tell me what to do, and I just do what they tell me to do. Now, academic integrity. We have a new academic integrity policy here on campus that deals with what's cheating and what's not. I think everybody understands, don't cheat in a class, right? That really makes sense. But more of a questionable thing is what constitutes cheating. So I have listed here some specific things like when you're doing homework, don't do it in a vacuum, okay? I know you're all smart people, but as Steve Martin said, 2 brains are better than 1. So when you're working on problems, try to look at a problem, get together with a friend, say, I understood this, do you understand that? Talk it out, and each person can improve their knowledge by working with somebody else. That's perfectly acceptable. On the other hand, if you just say, hey, Gabriel, I couldn't do number 3. Can I see your solution? And you just copy it. Well, you didn't learn anything. That would be cheating. So, it seems like a fine line because I want you to work together. I think it's better for you. But I don't want you to just copy. I want you to think things through and have your understanding of the problem and not just the other person's. So I have here, it's inappropriate to copy another person's work. It's unacceptable to give your homework aloud to somebody else so that they can use it, right? The person who gives it says, here, cheat off of me. They're also showing academic dishonesty. Another one came up last year. I give you, when we get to the points, you get credit for participating in answering questions with the clickers. Not counting today for the obvious reason, can't do it. But, what if you step out to go to the bathroom and a clicker question comes up? Well, then you're losing your participation credit, right? And so people are, Jim was just here, so I'll just answer for him so he gets his credit. Well, that's cheating, right? Because Jim wasn't here when the question came up. Jim didn't answer. So that's another thing that, you should answer your clicker, but not somebody else's. Another thing that I'm not sure is here, but it comes up later. any exam where a student is found in possession of a cell phone. For some odd reason, I had a student using a cell phone during an exam last year, and I know Dalton caught a student doing it a few years ago. So I just made the draconic rule that if somebody has a cell phone in their pocket at their desk during a test, they'll just get a 0 on the test.
The voice connection went out.
Huh. I wonder if it times out. Well, that's still on. That one turned off. Hopefully we don't get feedback squeal here. You hear me again? Do you guys hear me over there in Southwestern? Most excellent. They don't hear me still. I really don't know what to do, but Denton, that's why you're here. Yeah, we figured that out. This does have its low battery light on. I don't know. I will leave it to you to figure it out. Hey, that's not going to help. It's not muted. So here, you work on that. I'll keep teaching. I'm sorry.
Where's it coming from?
Working on.
Do you want to use my sound?
Yeah, go ahead. I don't care. Okay, moving on because we do. Yeah, that's a bad idea. Because we do have to keep going. Things that are going to make up your grade. Okay, I have listed here the things. Clicker participation. That grade is just what percentage of the days were you answering questions. And so if you answered 60% on a given day, you'll get credit for participating that day. Now, it's not just that. I'm going to make little flashcards, and I'm going to be lecturing, and then I'll have a clicker question comes up, and ask a question. Now, if the question has a lot of people that are wrong or something, we'll discuss it. You'll discuss with your classmates to try to figure out what you're thinking wrong. I'll re-poll it, and then I'll have a little card, and I'll just flip it over and say, choosing a random name, Hannah, give me your explanation of your answer. And then you'll give an explanation, and I will be giving a qualitative grading of, your quality of thought in that answer. And so those two things will go together for the clicker participation grade. Then we have the concept coach. Our textbook, a free text question in the back. Yeah.
So to clarify, we do not get penalized in clicker participation for getting an answer wrong.
That is correct. I want people to participate and think. We're learning. I can't expect you to be right every time when you're learning, right? The test is where I expect you to be right. So yeah, it's participation. And I do want people to honestly participate and not just, as a student last year, as soon as there's a question, B, and not paying attention to, that's not what I want. Okay, Concept Coach. Our textbook, which is an online textbook and is free, it has these Concept Coach questions, which are questions on your understanding of the concepts in each section. Those you'll have to do before coming to class for the material I'm going to talk about. So that's your evidence of having read the textbook before coming to class and understanding what it's talking about. For today, in theory, I'm covering all of Chapter 1. For Wednesday, I will be covering the first 3 sections of Chapter 2. So before class on Wednesday, I have the cutoff time at 10:55, so it's 5 minutes before the start of class. You'll need to do all the Concept Coach sections for Chapter 1 and then Chapter 2, 1, 2, and 3. So I will talk more about that later, but that is also 5% of your grade. Now, on these, if you don't have it done on time, I decided I want students to do this, make sure they have the understanding. So if you don't have it done on time, but you have it done before the exam that chapter is being covered on, I'll give you the score you had at the time it was due plus 50% of the score you got if you did it late. So that you can have some credit up to the time of the exam it's covered on if you didn't get it done on time. Then homework. The homework will be done on this website called Expert TA. Do they have sound? You guys have sound back over there in Southwestern? Yes? Okay.
Yes.
That's good to know. The homework will be done at Expert TA. That's the one thing you do have to pay. It's about $27-ish per semester. You get a 2-week free trial. So you can sign up now and go for 2 weeks. And by then you have to pay. If you want to put it on your student, I haven't talked to the bookstore yet, but this is what we did last year. If you want to put it on your student bill, last year what they did for us is students went over there and the bookstore actually charged it to their credit card and then put a charge to your student bill. That way students who have reasons why they need to be on their bill rather than personally paid can do it that way. If you're going to pay with the credit card, you can do it that way and just do it online. And we'll go through that again in just a few minutes. Next to third to last, laboratory. We have laboratory. Those experiments are where you actually get to see that what I try to teach you in class actually works, right? It's where you get to explore and see that physics is actually working, because nowhere in college should you be indoctrinated. We're not here to tell you this is what to believe. And surprisingly, physics research shows that even the best students, they tend to learn what the teacher wants them to answer, but not necessarily believe it. And so the goal of the lab is for you to see how it works and to be convinced that that's really how it works and not just, well, that's what the teacher says, and so I'm going to answer the teacher's answer. And the laboratories I'll explain in the laboratory period. We have exams. I believe it's 4 midterm exams. Why 4? Because I used to have 2 and students said that wasn't enough tests. So I believe it's 4 now, midterm exams. And then there's a final exam. Each exam is weighted equally. And your lowest exam won't count toward your grade. That includes the final exam. So for instance, if we come to finals week and you have an A with everything turned in except for the final exam, you don't have to take the final exam because it's just going to be dropped and you'll have an A. So you get 1 drop exam that includes the final exam. Now the 4th exam is only like 2 weeks before finals, so the material will all be covered in the first 4 pretty much. So the final exam can only raise your grade. That's the good news. Can't lower your grade. Okay. The next things are just the discussions of what we talked about. I'm going to go specifically to information about concept coach and homework that's not in the syllabus to explain those, so I'll save that for later. The attendance policy. This one here is a little unique. I spent a lot of time taking attendance this morning. I'm going to talk to somebody at Southwestern and have them do the Southwestern students separately so we don't spend all this time like we did today, especially because I couldn't tell who was answering anyway, for the most part. But Union College allows 3 excused absences for college activities. And so I figure I'm going to consider 3 absences a perfect attendance. This is my 1 effort grade part of the class. If you are here at the start of class, at 11 o'clock, and you stay throughout class, I've actually had people do this. You don't come in and then leave for 10 minutes as soon as I've taken record, go get a bagel or something to come. I've had people do that. But if you're here throughout, paying attention, not on your cell phone, you get 3 points. If you come within the first 5 minutes and then you behave appropriately throughout class, you get 2 points. If you're more than 5 minutes late or if you're gone for extended periods of time, you get 1 point. And since I allow 3 absences as perfect, if you have no more than 9 points lost, for people in physics 251, it's actually 12 points. Then I give you a big boost in your grade. I consider big, 2%. That's essentially raising you half a letter grade, from a B to a B plus or from an A minus to an A. That's my effort grade. So, it helps to keep people interested in coming to class at least. If you have questions, please feel free to ask from both classrooms. If you're falling asleep, I'm sorry. Okay, the exams. I talked about the grading at least before class. What I care is the students show that they understood how to solve the problem. So you get 2 points just for drawing an appropriate figure that outlines what you need for the problem. If you're doing something that's like a force problem, you'll need a free body diagram, an appropriate figure showing what's going on in the problem. Excuse me. Then you have the concept, which is where you explain, okay, this is what's going on. Now, don't make your explanation half a page. Some people do that. And, with this number of students, you know how long it takes to grade these exams? And if I have to read half a page for everybody to decipher, it's going to take a lot longer. So your concepts just needs to be this goes into this and makes this happen type of thing, right? Not long and drawn out, but something that shows you clearly understand how the problem works. So that's 3 points. That's the most important single point of the problem, your explanation. 2 points just for identifying this or these are the equations that I need to solve the problem. 2 points for actually doing correct math. And then 1 point for, in the end, getting the right answer. Now, if you just have an answer with nothing else, that'll get you 0, because your answer does have to have something to back it up, not just, well, I took a guess and went with 5. So you can see answers are not the important thing here. It's the process, it's the understanding, the critical thinking. Minimum grades for each letter grade. I do round, so 93%. If you're 92.5, I'll round up to get that. And you notice there's no C-. I believe a C- is a passing grade. I fundamentally think that that's an acceptable grade, but Union College doesn't. And so I just took it away. And so I would have had, following the scheme, a C would have started at 73 and a C- at 70. But since they don't consider a C- passing, I just made a C start 70 and I don't give a C-. Okay. I think this is the final thing on the syllabus, the course assessment. How am I going to determine if this was successful? Well, there's a number of things, and you have a document that shows the different things I'm going to use to assess it. It actually tells you the kinds of, on this exam, I'm going to have a question like this. So you can actually look at that course assessment thing and figure out, well, on this exam, I better make sure I know this because that's something he's going to ask on the test to assess a certain thing. And so, just look through that because it'll help you sometimes in preparation. Okay, I've got my class schedule. Today's the first day. You came in not prepared, I assume, but in the future you can be prepared because we have everything we're doing here. So first of all, for today, I'm, in theory, lecturing over Chapter 1. In practice, I don't think there's a chance I'm going to get through much of Chapter 1. It's okay because we have lab where we'll pick up some more. And so you can see the sections we're doing. Tomorrow for the Physics 251, I'm going to be doing a calculus review, which for a lot of people is, I've never done never seen a double integral maybe, So that's what we'll be doing tomorrow. And then you can see for lab tomorrow, we have pre-test and measurements. That's the first part of the assessments is the pre-test. I'll give a pre-test and a post-test and measure how much you improved. It's a way to assess learning. And then you can see Wednesday, blah, blah, blah. What this doesn't show is homework. Why? Because there's a homework assignment due after every class period where I actually lecture over material. So if it's a review lecture, there's not going to be homework due. But if I'm lecturing over new material, there's going to be homework due. Now, in theory, I'm going to lecture over new homework today, but there is homework assignment that's due on Wednesday, the first homework assignment. That homework assignment should take you no more than 5 minutes. That homework assignment is, how does the homework site work? So it has 2 questions, and it actually asks you to put in wrong answers and things like that so that you can see how it works. There's some where it doesn't give you any question. It just says, click the hint or type in this number. Oh, you were wrong. Click the hint, So it's just so you understand the process. I will go through and give everyone who scores over, I think it's 80% is my threshold, 100%, because you should be over 80% if you followed all the instructions. Question?
Is the expert TA site the homework site that you're running?
Yes. Okay, and you can see here in red where the exams are. I know it's black and white copy for the syllabus, but you can see where the exams are. Days where we have no class, Labor Day, fall break, and Thanksgiving break. And, of course, when all the labs are. There is a laboratory skills test. That's going to be where you have a paper test in the laboratory period where you answer questions like, why is it important to have units? How do you determine uncertainties? How do you make a graph? Those kinds of things. And then you'll also have to go do one simple little experiment by yourself. It's a really simple experiment just to show that you can think your way through it and do it. Any questions so far?
I just wanted to clarify, the exams are during lab time?
Yes, the exams are during lab time. The entire lab period will be devoted to exams. Is there a question? No? Okay. Thought I heard something come from the mic. Okay, Union College has this new academic integrity policy. You've probably already seen it in class today because they asked us to present it in all of our classes today. So read through this. It's kind of a unified how we're going to deal with situations where there have been violations of academic policy or academic integrity policy, and it lays out things you should and should not do. There's a typo on my version here, but hopefully it's correct in yours. I think I used the updated one, what I gave you. So just read through that. I'm not going to read through it myself. I trust everyone here has appropriate reading skills to read that. Okay, concept coach. We have 7 concept coach sections you need to do by Wednesday. So this thing is going to take more time than anything else you have between, well, except for lab, between now and Wednesday. You need to start by going to this website here, and you will have to log in. You'll have to create an account. The accounts are free. There's no charge here. And then you'll sign in for a class, and this class has an enrollment code of traditional opposite. So you have that form. You can go to the Moodle course site. Let me see if I can find Moodle. I may not. Yeah, I still have it open here. So you go to the Moodle course site, and actually, I'm not logged in, and I am not going to put my password in, so I don't think it's going to work out here. Yeah. Actually, no, it did. It did it nice and hidden. So you go to the class site here, Physics 151, and I accidentally clicked on the class schedule. So you can just come here and go to the College Physics with Concept Coach textbook to go to the textbook website. Here's the instructions that you have in your handout that will have the link and everything you can click on if you want. So you can use that to get there even if you lose the handout I gave you today. Likewise, I have Expert TA, the homework site instructions that come next. There's a Physics 151 version and a Physics 150 or 251 version. Everybody at Southwestern, you're in the Physics 151 version, so things that say 151, that applies to you. And so those give you instructions that I'll come back to in just a moment. Well, I won't go through them, but I'll point to one important thing. And, that gets you going for the homework and the concept coaches. Yeah, I'm not going to try to do a concept coach here because I don't know how the technology is going to work. The last thing here is the clickers. Turning Point, the company we use, has gone to a new model where everyone has to pay a license fee to use their clickers. Even if you have the physical clicker, you have to pay a license fee. Now, I'm not really pleased about having to pay a license fee after you've already purchased the clicker, but they're giving us free license fees for this school year. So that means you can do it without having to pay this year, whether you have a smartphone or whether you have a clicker. So you go to the Turning Point one time. You don't have to do this for every class, but one time you have to click this link here for Turning Account Registration, and you have to create an account, and you are going to have to pay the registration fee. And then you'll go down and click this Turning Point Cloud rebate to get a rebate to get back your registration fee. So you have to pay, but then you're going to get the money back. Everybody understand that? Excellent. Obviously, they're hearing me. Okay. So back to the presentation. The Expert TA registration, you can come and open that document we just saw where the links are. Click here. This here is the code for people in Physics 151 and people at Southwestern. It's in what I gave you in your handout. You can click on the form for Physics 151. The only difference in the form for Physics 151 and 251 is that number. So you're going to need to have that number to get into the proper class. And make an account using your email address and a password. This here, the student ID number. For Union College students, use the 6-digit number that you use to log into Moodle or everything else on campus. For the Southwestern students, for that student ID number, I hope it takes alphanumeric because what I'm planning on doing is using your Moodle login username as well. Your Moodle login usernames are just the email address I was given by Gerald Springer before the ampersand. So, Kim dot whatever. So that's what I hope you will put here because I use that to take the scores from the clickers and import them into Moodle so I can update the grades. You're obviously going to have to get down with the computer and spend some time before you know if you understand it or not. If you have questions, please feel free to contact me, email me, come by my office, whatever it takes, so we can get these things taken care of. So before class on Wednesday, everybody's gotten registered for both the expert TA and the concept coach. Now, one thing about the homework assignments are due at 11:59 in Moodle. It says 11:59 because I can't make 11:59 p.m. on the lecture period. Following the lecture period, the homework is over. So, for instance, today there's a homework assignment based on today's lecture. It's how to use expert TA. It will be due at 11:59 on Wednesday evening. The idea there is you can come to class and ask me questions the next class period if you have homework, questions, and then you still have time to get it turned in. Everybody understand when homework's due? Okay, when are the concept coaches questions due? They're before class, and it's 5 minutes before class is where the cutoff is. Homework is, and you guys understood, I'm not going to go forward on that. Remember, with the homework, you can do that 14-day trial to get started, so you don't have to have money today to get started. And that 14 days comes like after the last day to drop. So, don't pay now and then decide tomorrow, I think I'm going to drop. At least wait until after the last day to drop. Then you're committed and you can pay. So I think I made this clear. When are we going to meet next? Tomorrow at 2, unless you're in Physics 251. Physics 251 people will meet at 11:30 in the morning and at 2 in the afternoon. Okay, that's, of course, just to see if you paid attention. When's your first assignment going to be due? Okay, the first assignment would be at 10:55 on Wednesday with the concept coaches. Like I said, this is going to be 1.1 through 2.3, which is a total of 7 chapters worth of, or not chapters, that'd be a lot. 7 sections worth of content. All right. Now we're ready to at least get to the textbook and start talking about physics, because so far we've had no physics. I got 10 minutes left for physics. Our textbook is College Physics from OpenStax. So this is just a shortened URL to get you there. You go there, boom, there's the textbook. It's free, it's open. Actually, let me go back to the web browser and do that. Back to the web browser, I said. And go to the textbook. There's links for the textbook all over the place. There's one. So I click on the textbook, and up will pop, at the amazing speed of smell, textbook. Really, truly. I wonder how much you guys are getting when it takes that long for it to load the web page, since they're getting everything over the internet. So here is the first introduction section of the textbook. Not much exciting there. You can click on the top here, next, to go to the next section. Now the next section, hey, this has content. Yay. 1.1, got the questions. Notice up here at the top, it has jump to concept coach. If you already feel like you know the stuff, now you can look at the textbook on one browser page and take the concept coach questions on the other browser page, right? You don't have to have just the browser or just the concept coach. But this here will jump you to the bottom where concept coach is entered. And if I click here, then it's going to take me through the enrollment and logging in process. So I'm not going to go through that right now. Question?
Are these timed?
No, they are not. They are only one try. And as you get further in the textbook, it will give you questions from previous sections you've done in addition to the ones in this section to review. So you will have like the first, maybe there's 5 questions. The first 3 will be on that material, and the last 2 will be review over other stuff to make sure you didn't forget it. So that's how the textbook goes. Now, what if you want a print version? If you want a print version, you can purchase one. It was like $39 last year. I was reading on their website, and they said, $48.50, I think, this year. But it's a high quality printing. It's not a cheapo printing. So if you want a hard copy, you can have, you can order one and have a printed copy as well. But it's a free textbook. I hate the idea of students spending $250 on a stinking textbook. And so I'm trying to find something that works out the best. You can have it free, or you can pay a much lower fee and have a nice printed copy. Everybody understand the textbook? All right. So, our first physics thing. What do physicists do? I went to visit my parents in the Philippines once, and my dad says, "This is my son, Dr. Richard Webb." And they're all, "Oh," they thought I was a physician because he said doctor. Now, no, I'm doctor in physics. And I didn't know you could do that. Well, yes, you can. So physicists are trained to study the physical world, things like this desk, physical things. And so we're trying to understand why things occur in the universe. And the goal is to find the most basic laws to explain how things are happening. So you might wonder about things like over in Geneva, they have CERN. Actually, I say Geneva, it's not exactly there. They have CERN where they have that Large Hadron Collider. In Texas, they had built the superconducting super collider. We had a teacher here whose husband, when she was going to school at Southwestern, actually worked on the construction of that superconducting super collider. We spent, I think, billions creating what would have been the same thing as what they have over there in Geneva at CERN. And then our Congress said, "Oh, that's too much money." And so they spent a lot more money decommissioning it and never went online. Why do they do that? Why do they spend all this? Okay, why does Congress spend money for no reason? That's a different question. But why do scientists want to spend all of this money to essentially study what happens when you make 2 little particles hit each other? Any ideas at all?
And search for a grand unified theory of physics.
Okay, they're trying to search for a more fundamental understanding of the universe. We understand a lot of things like how balls bounce, right? We're pretty simple on that. It's easy. But to understand the fundamental forces, they're studying more important or more difficult things. And, I saw an article this last week that suggested there's another fundamental force that accounts for if you have a muon instead of an electron orbiting a proton, you have a variation in the energy level that was unexpected and suggests that maybe there's another force involved that we didn't even know about. They're trying to understand very fundamental things about our universe, and a lot of us tend to think, fundamental things that don't affect us at all. But think again about the cell phone. The cell phone it would not be possible to have this phone this size if we didn't have transistors. And those transistors are based on a quantum physics phenomenon. You had to understand quantum physics before you could make that device. And so that's the kind of things that physicists are trying to find. So here's examples of things where physics comes into play. Things like being able to do a CAT scan of a person's brain, understanding how the birds navigate. Obviously, I talked about the phone. The microwave oven, one of those happy accidents in science where a worker found that his lunch was heated up by having it set on top of the microwave equipment that they were using for research, and realized, hey, we can excite rotational modes and atoms of water with these microwaves, and we can cook food by transferring energy that way. And then we have, truth. That's way outside of my realm. The actual workings of these membranes is governed by physics principles, but I've not studied that area because nobody can know everything. Now, as we study physics, I'm going to be using a lot of words, and those words may not be familiar to you. I'm also going to be using a lot of mathematical calculations. Those also might not be familiar to you. And, of course, as the teacher, it's my whoops, don't touch the microphone. As a teacher, it's my responsibility, really, to give you the ability to understand and teach yourself and learn, but that means I need to make sure that I give you words that you can use. So I will try to explain the jargon and not just throw out words that you don't know and assume, oh, they'll know that. And a lot of words that we use in everyday life have specific meanings in physics. Things like work. I'm working right now, right? I am up here sweating away, right? Especially probably the people looking at the video see my shiny forehead from that sweat on it. In physics, we're going to talk about mechanical work, which is a force that is combined with something moving parallel to that force. It's a very specific definition. And so what I'm doing up here, if I just stand still and yammer away, there's no work done, according to the physics mechanical work definition. So we have some specific definitions where you know the word, but you don't really have the physics understanding. A lot of people get confused with words like power and energy and force. They tend to think of them as just one mushy thing that's the same. And we'll learn to differentiate them and what they mean. So here's an example of words. Speed versus velocity. When we drive our cars, we usually just say, yeah, I was going this fast. Officer, you shouldn't give me a ticket, man. And we talk about the speed. Speed is the rate at which we're changing position. It is the distance we've traveled divided by the time it took. But then we have this word velocity, and you hear that used occasionally as well. And velocity is related to speed, but not the same thing. Velocity is what we call a vector. It has direction as well as the speed. And so if I am driving down the freeway from Lincoln, Nebraska to Lincoln, California, I'm basically driving 85 miles an hour west. And so that's a velocity if I give you the speed and the direction. If I just say I'm driving 85 miles from Lincoln, Nebraska to Lincoln, California, 85 miles an hour, I've only given you a speed, but not necessarily the direction. So it's a speed, not a vector, so not a velocity. Now, sadly, the reason I use these as an example is I make mistakes. And that's the biggest one I'm going to make mistakes with. I will say speed when I mean velocity, and velocity when I mean speed. I try, I really do. But just like I don't expect perfection out of you, I'm going to make mistakes too. Okay, this will be the last slide I even bring up. Some other words. People are really familiar with things like you weigh yourself. That scale says I weigh an ungodly sum of pounds. But I might step on a different scale and it says kilograms instead of pounds. Well, what's the difference in a kilogram and a pound? I know it says it up here, but they're not even the same measurement. A kilogram is a measurement of mass. It's how much stuff you're made out of. A pound is a measurement of force. It's how hard you're pressing down on the scale. So if I go from here to, let's say, Pikes Peak in Colorado, I will have gone up roughly 14,000 feet in elevation. And as you go up in elevation, the acceleration of gravity drops, and so I would weigh less. The number of pounds that scale tells me will be a smaller number if I go from here to Pikes Peak. But that doesn't mean that I've lost any of the material I'm made out of. So my mass can stay the same. To make it more graphic, if I were to go from here to the moon, I would only weigh 1/6 the amount I weigh now. I'd look at that number and I'd say I'm malnourished. Probably still possible to live, sadly, but malnourished to say the least. But if you look at my mass, it'd be the same. So those are significantly different things. And it's actually really a problem for some physicists like me when you step on a scale and it says you weigh this many kilograms, because it's not saying you weigh that many kilograms. It measured how much you weighed, and then it calculated how much your mass is. Okay, so we're going to end right there. I'll see you for class or lab, next class period. Hopefully we won't have sound issues next time.